Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we will continue our lesson on Introductions to Scientific Programming, chapter 11, which is all related to the data interpolation. Okay, so these are the objectives for today's lesson. So after you finish this chapter, it is expected for you to perform 1D interpolations on a dataset by using function interp1 with a bracket. And the second objective for this chapter is for you to write MATLAB code to find unknown values between some known values. And the third objective is to write MATLAB code to plot interpolated data. And the last objective for this chapter is to understand the basis usage of interpolations on engineering applications. So basically, in this chapter, what you will learn is you will learn about interpolations and how you wanted to code interpolation inside MATLAB and how you wanted to applicate the applications of interpolations in engineering problems. Alright, so let's continue. Okay, so the first part of today's lesson is what is interpolation? So interpolation is actually a mathematical process of estimating unknown values between known points. Okay, so for example, if you have a point between 1 and 2, we wanted to know what are the value between point 1 and point 2. So those is called interpolation. Okay, for example, MATLAB plot function connect data points by drawing a straight line between 2 points. So the straight line values is the result of interpolating the 2 points. So later on, I'm sure that right now you are not able to understand what is interpolations. But later on, I will show you some examples in order for you to improve your understanding about interpolation. Alright, so this is the comparison between interpolation versus curve fitting. So maybe some of you already heard about curve fitting. And what are the differences between interpolation and curve fitting? So the first comparison is interpolation. It compute missing values between 2 points, but curve fitting will convert their data points into mathematical equations. So the first comparison is that in interpolation, it just finds the missing point. And the curve fitting is it will get the data from the available point and it will convert it into mathematical equations. Alright? So the second comparison is original data points are preserved, but in curve fitting, fitted curve does not need the original data points to be on the graph. Okay? So when we go back to the definition of the interpolation, so it only finds the missing point. So it means that it will keep the original point. But curve fitting, it will take all of the sets of the original point and convert it into mathematical equations. And from that mathematical equation, it will comes out with a new points. Okay, so it means that the original points is not being preserved. Alright, so that is the difference between curve fitting and also interpolation. Alright, so next we will go through for 1D interpolation. Okay, so the syntax for 1D interpolation is VQ equals to interp1. Okay, we have X, we have V, we have XQ, and we have methods. So what are those variables? So for X, X is defined as sample points. Okay, so in the graph later on, you will see that X is represented by the data of in X-axis. Alright. V is actually the corresponding value of Vx. So V is actually the output value of X. Okay. XQ is the interpolated query points. So XQ is actually represented the distance between the missing points. Okay. So when you wanted to find the missing points, you must know what are the distance between the missing points. So later on, you can see what are the definition of XQ and X and also V. Next is the methods. So in interpolation, there are several methods available in order for you to interpolate the data. Okay, so interpolation methods, it has what we call a total of I think 4 methods. Okay, so later on we will see some of the available methods. Okay, so the default method is linear if it is not stated. So if you are not stated any methods in this syntax, so it will automatically return as a linear type. Okay, so VQ is actually the written interpolated values. So when you use this syntax, so all of the interpolated data or interpolated points will be stored inside variable VQ. Okay, or any variable that you give the name. So you can give the name of anything. All right. Okay, so next we go through with some of the interpolation methods. So below are the variation of the interpolation methods. So each methods will return different interpolated values. So of course, when we have different methods, each methods will return different values and also different pattern of the data. Okay, so we have a total of 4 methods. Okay, so choosing the right interpolation method depends on the characteristic of the data to be interpolated. So later we will discuss a few examples with different interpolation methods. So in interpolations, what you must know is that you must choose the suitable method for you to be interpolated. So later on we will go through some of the example and define what are the most accurate methods to be applied for interpolation. Okay, so the first method for interpolations is nearest. So nearest is defined as the nearest neighbor interpolations. So this method sets the value of an interpolated point to the value of the nearest existing data point. So for nearest methods, it only compute the missing data. It finds the missing data based on the shortest distance between the neighbor. Okay, so this is the nearest. So in order for you to use nearest methods, you need to have at least 2 points. Okay. Alright, so next is the linear. So linear interpolation uses straight lines to connect the points. Okay, so for linear methods, what linear method does is it will connect each it will find the missing point by using straight lines. Okay, so it means that when it has 2 points, so it will automatically compute a straight line between each point. All right, and then it will find the missing point which is situated inside the line. So for linear, you must have at least 2 points. Okay, so next is splines. So spline is piecewise cubic spline. So this is identical to the spline functions. So spline is like it is like smoothen out the data. Okay, so later on you will see it has a little bit of curve. So you must have at least 4 points because you wanted to initialize a curve. So you need to have at least 4 points. So PC chip is a piecewise cubic Hermite interpolations. So you must have at least 4 points. So the difference between spline and PC chip, so the difference is that spline doesn't have any edges. It just have a smooth line. But PC chip has edges. It still curves, but it has edges. So after this, I will show you some of the differences between each of the methods of interpolation, so you can understand. All right. Okay. So this is the example number 1. So example number 1 will show you what are the differences between each interpolation methods. Okay. So below is a MATLAB script on visualizing difference between the interpolation methods. So first, we initialize the value of x of 0, 1, 1, 0. Okay, so if you are using what we call the value of x here, all right, so when you go back to the syntax, x here represent the functions of n1. Okay, all right, so n1 is actually defined as from 0 to 3. So it means that n is 0, 1, 2, and 3. So n1 will be shown in the x-axis of the graph, and x data or x variable will be shown in y-axis of the graph, because when you see this is the syntax, so inter p1, this is the n1 which is represented in x-axis. X is the function of n1, okay, which is the output that you get from n1. All right, so x will be represented in y-axis, okay, and then n2. So n2 is actually the distance between the missing point, okay. So it defined as 0 to 3 with a difference of 0.2. So it means that n2 has a lot of points, okay, 0, 0.2, 0.4, 0.6, 0.8, and so on until it reaches number 3, okay. So the first part is we are using the nearest type, and the second type we are using linear type, the third type we are using spline type, and the fourth type we are using PC chip type, okay. So this command is just we wanted to plot each of the data differently, okay, and this is the line style, different line style, in order for you to differentiate, okay, the different line style for you to differentiate each methods of interpolations. Okay, so this is the label and also the title and also the legend. All right, so this is the output that you get from the previous code. Okay, first, what we wanted to see first is we wanted to see the original points. So the original points here is represented by a big circle. Okay, so you see here we have 4 points, 1, 2, 3, and 4. So this is the original point. Okay, so what interpolation does is it will find the missing point between this point to this point to this point and to the last point. Okay, so it will find the missing data. Okay, so when you are using the interpolation method, so let's take a look at the first method, which is the nearest. Okay, so what nearest method does is it will find the missing data from, for example, if we see from this point to the next point, okay, it will find based on the nearest what do you call the nearest value. Okay, so you see here when we see the codes, okay, you can see here the distance between the missing data is defined as 0.2. Okay, so it will find the what do we call the distance, which is this is the missing data. Okay, this is the missing data. So the 0.2 value will be represented in x-axis. Okay, see here. So this is the original data, and then the nearest neighbor, okay, is here 0.2, and then 0.2, and then it goes here, which is the nearest to the next point. Okay, 0.2, which is 0.6 here, and 0.2, which is 0.8. Okay, so the distance between each missing data is 0.2. all right, okay, so this is what nearest neighbor found, where it will compute the missing data based on the nearest value from the points. Okay, so this is the nearest, this is the nearest, this is the nearest, this is the nearest, and this is the next original point. Okay, so this is what the nearest interpolation does. All right, so next, the linear. Okay, so what linear interpolation does is, first it will automatically connect each original points in a straight line. Okay, we'll connect each original point in a straight line, and then it will find the data based on the distance between each missing point. So it has been defined as 0.2. So 0.2, 0.4, 0.6, 0.8, and 1. Okay, so first it will compute the straight line, and then it will find the data, missing data, based on the distance between the missing data. All right, so this is what linear does. So spline, what does it do is it just compute like a curve between the original points, and then it will find the missing point based on the distance. Okay, so the distance, you must remember that it will be defined in x-axis. Okay, 0.2, so it will not reflected to the y-axis. Okay, 0.2, and then you can see here, right, the value of each methods will correspond to each other. Okay, so you see here the value of x-axis will correspond. All right, and lastly, the PC chip is like a cubic, so it has a curve, but it also has edges. Okay, so you can see what are the differences between each methods of interpolation. So later on, when you have a problem, you must know which one of the methods that you must use in order for you to improve the data for your experiment. Okay. All right. So next, let's take a look at some of the interpolation applications. Okay. So in engineering, especially electrical engineering, interpolation is very useful for the following. So in electrical engineering, we must use interpolation to evaluate unknown values between known points. And the second is to increase the details of the signals. Okay. So if you have like data with a low sampling rate, so it means that in 1 minute you only recorded 2 data. So how you wanted to know what are the data between 2 seconds? So in order for you to do that, you need to interpolate it. Okay. So next is increased detail of a signal. So if you have a signal which lacking some details, what you must do is you must do some interpolation. But you must remember that you need to use an accurate interpolation so that you will be able to preserve or improve your signal accurately. Alright. So next, we'll take a look at some of the example of interpolations. So the first example is to evaluate unknown values. Alright, so let's take a look at the next example, example number 2. So this example is all about the air pollution index. Okay, so example number 2. Above figure shows an air pollution index reading during a haze crisis. So practically, the API sensors were installed at selected discrete locations. So you see here we have Kulai, Senai, Skudai, Perling, and Johor Bahru. So those are recorded in discrete location. It means that it is not continuous. So it is one in Kulai, one in Senai, one in Skudai, one is Perling, and one is Johor Bahru. So it is not continuous. Okay, so assuming the API is linear between 2 sensors, write a MATLAB code to compute the API values for every kilometer from Kulai to Johor Bahru. Then find the API value at kilometer number 10. So what this question or this example wants you to do is, they wanted you to find the API value here, or here, or here, or anyone, or at any place. Okay, because it says that assuming the API value is linear, so it means that the API value is assumed to be continuous. So the distance is basically also continuous. All right. So what you should do is, so to have an elegant solutions, we will create a MATLAB function where its output is a vector stating with which kilometers are the API reading is needed. Then the result will be shown at command window and a plotted graph. So what does this example does is, okay, so this example, it gives what we call this example give the application of air pollution index. Okay, so what the questions want you to do is, it wants you to find the missing data. Okay, you don't have the data at here, but the questions ask you to find it. So how we wanted to find it? So in order for you to find it, you need to use interpolation. All right. Okay, so this is the function API value. Okay, the function name is API value. The input is kilometers. Okay, first D is the distance. Okay, it initialized 0, 6, 15, 23, and 30. Okay, see here 0, 6, 15, 23, and 30. Okay, and API is the functions of D. Okay, so the output of API is hundreds, 180, 199, 280, and 310. So from here, what you can see is that D will become the x-axis and API will become the y-axis. All right. And also D kilometer is actually the distance between the missing point. So you wanted to find the data in each kilometer. Okay, so this is the colon operator, right? So you already learned about colon operator in the previous chapter. Okay, so API kilometer is equals to P1 interpolations D, okay, which is the value here, which is represented in x-axis later on. API, which is the output of or the function of D, which will be represented in y-axis, and DKM. So DKM will be represented in what we call the distance between the missing point. So you can see here in this function, it doesn't initialize any methods for interpolation. So automatically it will initiate the interpolation as a linear method. Okay, so this is why equals to round, you just round the number and you just print the value of API, and then this is all about the plotting the graph. Okay, all right. So when you use this function, when you put the value here, so it will show you what are the API value at what kilometers. Okay, so you can also put the colon operator here, so it will compute in each operator, in each kilometers that you compute. Okay, so this is the result of several input vectors, so you can put any value that you want. Okay, as long as it doesn't exceed 30 kilometers. All right, or I think you can also exceed 30 kilometers, but the value will become not valid. All right. Okay. So this is the graph that you will have. Okay, so this is the API calculation from 5 stations. Okay, so what you can see here is that the what do you call the circle, the big blue circle here shows the original point. Okay, so you see here the orange X, okay, shows the interpolated data. Okay, so as I mentioned it before, the linear methods will first connect each original point in a straight line, and then it will find the missing data based on the distance between the missing data that you have been initialized. All right, so in this situation, we are initializing the missing the distance between the missing points is equals to 1 kilometer. So it will find the value of 1 kilometers. Okay, you can see here from 0 to 5 we have 0, 1, 2, 3, 4 and 5. So this is the distance between each missing points is equals to 1. All right, okay. So next we'll take a look at the second example, which is VLE diagram. So what is actually VLE diagram? So in chemical engineering, so this is all about chemical engineering. So although you are electrical engineering, maybe sometimes you will be interacting with the chemical engineers. So maybe you can know about some of this, okay? So in chemical engineering, vapor-liquid equilibrium, VLE diagram, is used to analyze whether the vapor and liquid are pure, which they consist of only one molecular component, or if they are a mixture. So constructing the VLE diagram is done by taking mole fraction values for both vapor and liquid at several temperature values. So then the VLE diagram is plotted on the vapor mole fractions in y-axis versus the liquid mole fractions in x-axis. So below is a table of vapor mole fractions and liquid mole fraction values for 11 different temperatures recorded at 1 atm for benzene toluene. So from the table, determine y at x equals to 0.45 using interpolation methods. So here, the questions already describe to you what are the data that you need to put at x-axis and what data is you need to put at y-axis. So at x-axis, you need to put the liquid mole fraction, and at y-axis, you need to put the vapor mole fractions. Okay, so the conclusion from here is that, okay, what you need to do is you wanted to determine the value of y at x equals to 0.45. Okay, so by plotting the VLE diagram as below, it shows that the graph is not linear. Okay, so when you are plotting the graph of VLE, it shows that your graph is not linear. The graph has some curvature, stating that the best interpolation method should be SP-line or PC chip. Okay, so this is where you can define what types of interpolation method is the best or it's better for you. Okay, so when you compute or when you draw the graph, you see that it doesn't have any linear. So it means that it doesn't have like a straight line, okay, or it doesn't have like a vertex or edges. Okay, so it means that you cannot use neighbors and also you cannot use some linear, but you need to use spline or PC chip. All right, so below is the MATLAB script to plot the VLE diagram and to find the y values for SP-line and PC chip interpolation methods. So from this data you can see here, all right, so this is already defined. So this question already defined what you need to put for x and what you need to input for y, right? So for x, okay, x is actually the data, okay, y is actually the function of x, okay. So what you need to put is, this is x and this is y, and then y spline, okay, this is the you are using the spline functions or the spline methods, interpolated x, y, and also because these questions already ask you to find at specific point, which is x equals to 0.45, okay. So what you should do is you just put 0.45 here, all right. So it will automatically find the values of the y at 0 when x equals to 0.45, okay. So before this, when you see the example before this, you are using colon operator, okay. Okay, so it means that this one dkm, okay, this is the distance between the missing points. You are using what they call a colon operator from 0 to 30 with the difference of 1. So it means that it will compute each and every missing points from 0 to 30. But this one, it will find only at when x is equals to 0.45. So if the questions ask you to find only at 0.45, you just need to put only one value here. All right, and then it is as usual. You wanted to display what are the values. You wanted to plot the data, okay, and you wanted to turn on the grid. All right, so all of these things you already learned in the previous chapter. Okay, so this is the one that you are learning in this chapter, which is how you wanted to use interpolation. So if the questions ask you to find only on one point, you can just put 1 point here, okay. So if they wanted to find a multiple point, maybe you can do again the second one or the third one, or maybe you can just put the colon operator here. All right, okay. So next, let's take a look at the next example, which is to increase the details of a signal. So this is the second applications of interpolation in electrical engineering, okay. All right, so this is the example which is related to the electrocardiogram, ECG. So what is ECG? So an electrocardiogram, ECG, records the activity of a heart. Okay, so for wireless mobile ECG devices, low energy consumption is significant, requiring low sampling rate of the heart activities. Okay, so the good thing is the low sampling rate ECG data can be made more accurate by applying interpolations. So usually, the ECG devices, maybe you can see the ECG devices in your smartwatch. So for those who have smartwatch lah, okay. So in order to preserve the battery, the ECG data need to be reduced. So it means that the sampling data need to be reduced. So for every 1 minute, only maybe one sampling, or for every 1 hour, only 2 sampling, because we wanted to reduce the battery usage. Okay, all right. But when we are decreasing the number of the data, it means that your data will not become accurate because you are not taking the data regularly. Okay, but the good thing is you can manipulate or you can increase the value of sampling by using interpolations. All right. So in this example, the heart.mat file is a sample of an ECG signal recorded at 60 samples per second, or 1 sample at every 0.0167 seconds. So this is still what they call considered as low sampling data. Okay, the sampling data that has been recorded is very small. Okay, so you need to record more. All right, because you know maybe the heart attack will just attack you in just little seconds. Okay, so increase the detail of the signal to 16 times of the original number of sample. Interpolation will add 15 new points. So interpolation will add 15 new points between each sample. So that is the power of interpolations. So interpolation method suitable to increase the detail of the ECG signal is spline method. So in this example, it is already mentioned to you what are the methods of interpolation which is suitable for ECG signal. You see that spline method is the most suitable one. All right. So below is the MATLAB code interpolating the low sampling rate ECG signal. So in this case, spline interpolation method is used. So it can seen from the plot that the peaks which were missing in the low sampling rate ECG signals are recovered with the spline interpolation process. So this is the example where we are loading the hard.m file. So later on I will give it to you, okay, after I get the hard.m file from the coordinator, okay. So this is all about the equations that you need to do, okay. Alright, so when you plot the interpolated data, so you see that here, this is the results, okay. So this is the original signals. Alright, so this is the original signals. You see here, after we interpolated some of the signals, actually we can recover some of the peaks, okay. So this is the peaks that are recovered from the original signals, okay. So in ECG, the peaks are really important, okay, because it can indicate what are your current conditions. So what is happening now, okay. So from here you can conclude that ECG signal can increase the detail of a signals. Before this, it doesn't have any peak, but after we interpolate it, we have a peak, okay. So it can improve the details of a signal. All right. So I think this is the last what do we call the last example, I think, maybe. Right, so this is example number 5. So I'm sure that you already learned about digital electronics this semester, right? So you must know this, okay. So example number 5. So digital to analog converter is a basic compute components to an electronic systems. So for example, a digital audio song played on a computer will be first converted to analog signal before the signal is sent to the speaker. So to improve the DAC output signal, a low pass filter is applied. So usually we are using a low pass filter. And to simplify the circuit of the low pass filter, signal interpolation is performed before the DAC. So this interpolation process is also called upsampling. Okay, upsampling is just, you can just take the definition of upsampling from the word itself. It is wanted to increase the number of sampling, okay. So you can see here, this is the original audio signal, all right. So you see here that there are some gaps between each signal, and then we interpolated it. So when we are using the interpolation, so you can see here that the number of signal has been increased, okay. So it means that the signal will have more details, okay. More signals equals to more details, okay. And then we will convert it from digital to analog, and then we are using low pass filter to remove some of the edges, okay, unwanted edges, and it will become a analog signals, okay. So what interpolation does is it just simplify, or actually it improve actually the accuracy of the signals. All right, so this is why you need to use interpolation, okay, because digital signal only collect the data in an interval of time, okay. So between the interval of time, you need to use interpolation because you wanted to find the missing data between the time interval. Alright, so this is the MATLAB script that looks at 4 interpolation methods. So this script will load the signal data. Okay, so this is the frequency, this is the time, this is the length, and this is the T and T2. So you can study these codes. Okay, so these codes is all about to improve the data of digital, okay, in order for you to get a better analog signal when you convert it. All right, so this is the example of using different types of interpolation methods for digital to analog. Okay, so this is how you wanted to increase the digital data by using linear, and this is by using nearest interpolation. So the nearest is not that good because when you see that when you compute this analog data, it will not become more that accurate. All right, so this is the PC chip, so the data looks good, okay, and also the spline, and also the data looks good, okay. And I think the most what do you call the most accurate or the most suitable, I think this is the spline have the better accuracy. All right, as you can see from the last part, okay. Maybe it has some curve here. All right, okay, so that's all for today's class. So I hope that you know what is the definition of interpolations, how you wanted to code the interpolation by using the syntax that has been provided, and what types of interpolation methods that you need to choose in order for you to have a good interpolation process or interpolation output, and If you have any problem, as usual, you can ask me into the WhatsApp and I will answer you accordingly. Okay? I think that's all for today's class. Thank you.